Good morning, people. This is tutorial number 18, which is modeling a telescopic mechanism in the 3D Experiences Release 2025X platform. Now, what we have here is three parts. The parts are the base. This is the base that's fixed in space, is not going to move. Okay, and I have a big tube and an inner tube, small tube, and the bottom of this big tube is going to be coincident with the point that's in the base, and that makes a spherical joint. This small tube is inside of that big tube, and it can go up and down. And that's going to be either a cylindrical or a prismatic joint. I'll make comments about that in a minute. And the top of this small tube is actually traversing that curve. Okay. Now, the only thing is that, first of all, if you make this thing uh, cylindrical instead of prismatic, there will be an extra degree of freedom that we don't want. That's going to go away. So I'll make this thing prismatic joint. And uh, notice that because the bottom is spherical and the top is the point curve joint, this whole thing, this whole clamp, this whole um, telescopic unit can actually spin about its own axis, and we don't want that. This is why you do a point curve joint, you do a prismatic, and a spherical joint. But then to take away that extra degree of freedom of spinning motion, you need to create a point surface joint. And the point belongs to the base, and it will go through this surface, and this surface really is the plane of either the big tube or the small tube. It makes no difference. So that takes away the spinning motion. So that's what this comment is about. First of all, we want prismatic here, not cylindrical. And then at the end, I want to create a point surface joint that may not be obvious why. This is the chapter. This is coming from chapter 12 of the textbook that was done 9 years ago. And instead of revising this book, I've prepared these video tutorials. Okay, let's go ahead and do that. Yeah, so we go here. We're going to start with an assembly. Insert the base. So right click, properties, insert, right click, insert 3D part. This is going to be the base. Let me rename this thing, or at least modify the name slightly so that we know what it is. Here's the base, and there's an instance base. Say okay. Let's double click on it and make it. Very simple. So on a horizontal plane, I will sketch a point, uh, that is 5 and 10 millimeters away. I can create a point here, or actually let me exit this. Just create a point. A point with coordinates x of 10 centimeter and y of 5 centimeter. So instead of doing it in Sketch, I created it right there. Okay. Now, I want to create an ellipse up there with which is 20 centimeters away. These dimensions really don't make that much of a difference, but I'll make a plane above that 20 centimeter, offset from this plane 20. Okay, and it's right up there. And on it, I will sketch that ellipse that I want. So here is the ellipse. Let me see. Let me see. I want this thing to be 20, roughly 20. And I want this thing to be roughly 10. Yeah. Okay. Exit. So there is my ellipse. And I want to create a point here because later on we're going to be using it. I mentioned to you why. So height of 20, and this is 0, and this is 0. Okay, so it's going to be right there. So what I have here is that plane, that point, and this point was already created 10 and 5. Okay, so that takes care of this. So let me go all the way to the top, insert, small 2, 3D part, and I'm going to call this thing small 2. Small 2. Yeah. Hmm. Let's make it. It's just a cylinder. So I'm going to double click on this thing. On XY plane, I will sketch a circle of radius 2. There's a circle of radius 2. Radius 1 centimeter. Actually, this is the diameter, so I'll make diameter 2. Good. Let me see for a second. Radius 1, diameter 2. Okay, fine. And exit. And had it by 15 centimeters. There we are. I also want to point on top of this, point on top of that. So let me make it point by circle center. I select that. So the point is created. Oops. Circle center. Try it again. Okay. Let me get rid of this. Clear this. It's easier if I just close it. Let me try it again. Point, circle center, select that edge, and there we are. And then we say okay. Okay, right there. Now, that takes care of this. So I'll go all the way to the top, insert, right click, 3D part. Let me call this thing big 2. Big 2. Two. Yep. Let's go make it. So double click on this. On a convenient plane, I'll use the same plane and draw 2 circles because it's going to be a 2, right? So this one, I'm going to make that diameter 4. And another one, the diameter 2. I could have projected that circle, by the way. Diameter 2. And then we say okay. Exit. And then pad it by 15. Good. And at the very bottom of this, at the very bottom of that, big 2, I'm going to make a point because later on I'm going to make a spherical joint. So that is going to be, well, it is 0, 0, 0, but I can say also circle and that circle. It's going to be the same point. Good. Okay. We are good. So let me go all the way to the top, move these things apart. So I'm going to use the manipulate. Oh, before I do that, let me just fix this in higher base. So under engineering connection, fix, the base is completely fixed now. Good. See that it's here under engineering connection. Now I'm going to translate this. I'm going to translate it in the direction Y. There we are. This is one of them. This is the other one. So, okay. Now, if we want, we can make the prismatic joint right now. Let me also move this thing a little bit up. So, so that I can see it better. Good. So, we need to make a prismatic joint here. So let's go ahead and get the prismatic joint. And the different ways of doing it, we'll do axis to axis, plane to plane. I'll do this one, axis to axis. What is that thing called? I'll use coincidence. I'll use this one. I'm not going to worry about the bottom, the constraint. So axis to axis, plane to plane. So here's what I'm going to do it. This axis and that axis, and then the vertical plane of this and the vertical plane of that. That makes it a prismatic joint. Now, we're not going to be controlling this thing, so I might as well get rid of that. I don't want any the last item controlled for control purposes. We don't want it, so we say no. Good. Now I'm going to take this point and put it there. That's a spherical joint. So we go here, we go to spherical. We can do point to point, coincidence between this point and that point, and then say okay. Don't worry about clash and update. There we are. Now I'm going to take this point and put it on that thing, on that curve. Now that, for example, I can do point curve joint. So I go to, I don't see point curve here. So I go to engineering connection, pull this thing down and find the point curve right there. And I'm going to make, for example, a point and a curve. Okay. So, and it's going to be controlled, right? It's controlled. So that's what this thing is. So, where is that? The point is right. The point is right here. It hop up this small tube, and the curve is right there. And then we say okay, no, and update. Okay, very good, very good. Okay, let's see if we can actually check things, see whether things work before we actually go and create the mechanism. So we go to once again move. What is that? Manipulate. I'm going to move that. I'm going to move this, but I want to keep the constraints in place. So I'll check that, and I'm going to translate this. You see, constraints are respected. And without that, if I just say, you know, you can just move it, but the problem is that constraints are not respected. That's why you go off position. So just close it. Good. So we are on the right track. Now that point surface joint, I can do it now, or I can do it later. Okay, so let's go ahead and do that now. So we go here. We won't see point surface, point curve, and some of these other joints here. So you have to go to engineering connection, hold this thing down, find the point surface joint. Okay, it says the point. I want this point to always go through either this plane or that plane, or this plane and that plane. It doesn't matter which one you use. So I'll use, for example, it makes no difference. I'll use this because just to convince you that right now this is not on the same plane. But when I create it as a new as a new joint, what it does, it kind of rotates this thing and makes sure that plane goes through this point. No, say okay, and a no, and an update. I guarantee you that this point, this plane that I picked, is going to go through that. You can see it already. Okay, good. Very good. So that takes care of everything here. So now we're going to go to a mechanical system design. You can go here or go there directly. That's entirely up to you. But let me, as in the other tutorial, let me go to mechanical system design and create the mechanism representation. Just create it. Here is the name. You can call it anything you want. You can call it you can call it the telescopic mechanism. Give it any name that you want. Just leave it the way it is. And then let's check our joints. Notice that there is a nice one here. That means actually the mechanism can be simulated later on. Point curve joint is length driven. You can see that. Say okay. We can always check. Go here to get the mechanism player. 1 degree of freedom, so this thing goes all the way around. Now I could have made these things a little bit longer so that it looks nicer, but that's easy to do. I can go. Let me actually go ahead and do that. So let me go to the big tube. There is the big tube. The path instead of I don't know, instead of 15, I'll make it maybe 18. I'll make it 18. Okay, good. So back to mechanism. Back to this. It's more like looks more respectable. Now I can make this thing also longer so that it looks nicer. So back to small tube. Here's the pad. Where's this pad? Okay, so I'll make this thing also 18. Good. And exit and update. And now you can check it out. It looks nice. Okay. Reset. Now this is just a cartoon. There is no physics here. But suppose I want to specify the velocity of this point on that track, on that ellipse. So in order to do that, you need more than just making the mechanism. You have to go to mechanical systems experience. And this is the name. And what we want, for example, is the speed of this. Now that means you want different ways of doing it. Law excitation is one. The support is that joint, and the command on it, that was a point curve joint. Oh, under the command, that's what I want. There, inspect it. By the way, this whole thing is 77 millimeters, this is centimeters long, just to remind you. Click on f of x. So right now I am at that location. For example, I can add to it. Plus. Let's make it 10 centimeters per second. 10 centimeters per second times time, and then say okay, and then say okay. Now we're going to create a kinematic scenario. This is the excitation that I created. We send it to the right side. Let's do it for 10 seconds, see how it's going to go. But this time step one is too big. Things are going to be very jagged if you do it like that. Say okay. I made it 0.1 and see how it looks like. And then we're going to compute. Okay, I think 10 seconds was probably longer than I wanted. Let's actually make it longer. So where's that scenario? Back there. I'll make this thing 30 seconds, probably 3 rounds. And I'll make this thing, I don't know, 0.05. Let's see how it looks like. And run it. 1, 2, 3. So that's fine. You got it to work. And that's pretty much it. Good luck.